Alright, so thought I'd make a little video explaining some of the electrical elements of the dollhouse that I built with my daughter for Christmas. Had some questions about how I did certain things. And even though this was my first dollhouse, so I'm not super knowledgeable on the subject, it came out pretty good. So anyway, thought I'd make a video explaining some things. First off, this box here, which is where the 40-watt transformer head came in. This is what powers the dollhouse, or takes the 120 volts from the wall that you would plug in and changes it to 12 volts for your dollhouse lighting. What's nice about this transformer is it's actually a little bit more than a transformer. The traditional transformer used on these houses would be able to take a range of bulbs for the size. So say this 40 watt is able to do something like 60 incandescent bulbs, but the voltage that the other transformers would put out were dependent on how many bulbs that you loaded it with. If you didn't put enough bulbs, the voltage would be higher in the closer to 15 volt range and your bulbs would burn out quickly. If you put too many bulbs, it would load it down too much and your bulbs wouldn't get enough voltage and you would pop fuses or breakers in the with the transformer. This unit has a voltage regulator, so even with only one bulb on it, it'll still put out the correct 12 volts and your bulb will have the maximum life. I'm using it to about half of its capacity with the house that I had built. So anyway, I highly recommend a transformer that's actually a voltage, which is actually a power supply instead of a regular just transformer. So in here, I just kind of threw some of the tools that I had used to build the dollhouse. We have, let's see here. One moment. Let's see here. This guy. Let's start with these four. All right, so this guy. This is a voltage tester. When you roll out this electrical tape wire as you're building it, you want to check your progress, and you can puncture the tape wire like this while it's electrified, and this has a light in the back that will light up and let you know that you have power to that point. I've seen a lot of people say that this type of wire isn't very reliable, and even though this is my first house and I just did it, I will say that I had no problems even while building it, no connections that didn't make properly. So I wonder if people's complaints were due to maybe poor installation, but it seems like it's working great for me. And so anyway, I recommend it. Anyway, so this is the tape wire. This is the little tester that would come in one of the wiring kits. This little guy here is a little jig that allows you to uniformly place the tape wire along the walls at the outlet height, so you could later find it after it's covered by wallpaper. You could use this along the floor, and it even has little holes in it where you could puncture and at the perfect spot to add an outlet or add a light fixture and all the different things that you can do with it. So I thought this was pretty useful. It's off to the side. This is a little drill, has a 3-to-1 ratio, and it is the perfect size for installing large eyelets. I think I had some large eyelets here to show you somewhere. There we go. These eyelets, these are the large. They come in two sizes, the larger of the two, and this drill bit is the size that you need to pre-drill to install these eyelets. Later on in the video, I'm gonna install a few to show you how that works. Also, if you'll notice on my drill, I got a little bit of tape here, and that's as a depth gauge, so I wouldn't go too far to blow through a wall. Like here's a piece of MDF here to blow through a wall or a ceiling. You know, I could move this piece of tape for the different thicknesses I had. All right, so this was a cool tool. I recommend that. And this guy is to drive these eyelets. I had to modify mine a little bit, cut it, due to me installing LEDs a little bit too close to a wall. So I cut this off a little bit. But anyway, you use this to install these eyelets, and I'll show that in a moment. This was a pretty cool feature in my in my dollhouse, or me and my daughters. This is a little switch. I don't know if you can see real good. And it has these little holes in it, which are the perfect size for these large eyelets. So you could glue this to the wall, over the tape wire run, cut a portion of the tape wire out to interrupt the circuit, place this directly over that portion that you removed, and then use the eyelets to connect it. And then you can complete the circuit or break the circuit with this switch to put working light switches in your rooms. Let's see here. Also, I thought this is pretty key when you're doing like a bigger thing. This is my little sort of electrical schematic, or really it's just a roadmap for where I wanted to run my wire as I was building. I have two separate circuits in here. It's a little hard to see exactly, but I have one that is for the LEDs, and they run home run to every LED in the house, and they work off of one switch that I put in the foundation. And these LEDs are bright so that my daughter could play and would be well lit, and then I could turn it off so it would look more realistic with all of the real incandescent fixtures that I bought, lamps and light fixtures. The other circuit, the fixture circuit, it powers all of the outlet runs, it powers all of the switches, and then on from the switches it goes to the individual light fixtures. There's a lot of redundancy built in. I have actually 4 runs coming out of the basement to power all this stuff, just for redundancy, mainly because I kept reading that this may not be the most reliable. So I added a lot of redundancy in case there's any one failure point, everything will still work. But I haven't actually had any failures, so maybe that was a bit overkill. Let's see, so let me move on to doing a quick demonstration on how this works. This is a piece of MDF. Normally in the house you would pre-paint this with some white primer paint and then sand it, and that gives a really good surface for this tape to adhere to, but for the purposes of our demonstration, that's not needed. So let me put a little bit of this tape wire down. All right, it's a little bit messed up, so I get us a little length of it, and maybe long enough that I could put a bend in it. I just gotta cut this. Let's cut this with. There we go. And you would just peel the backing, place it down, smooth, and then just to show you how to make a bend, when you want to make a turn, let's say we're doing a 90-degree up, you would bend it away in the direction you want it to go, and then towards. Peel that out. And you can make this go any way you desire. Let's say we want an angle going this way. I would then bend it that way. And I use this to extend it to kind of also help me line up. Say this is a roof line or something, get the angle right. So say there's my angle. I'll put that down like that. Peel a little bit. And then boom, we're going this way. And then let's make a Z. We'll go back this way. So again, we want to go the opposite way first, like that. And then we bend her back. All right, well, I ran out of tape wire, but you get the idea. Yeah, so anyway, that's how you would run it and how you would bend it. These little extra thicknesses aren't that noticeable under thick wallpaper. And then let's say I was installing a switch. Say my power's coming in here, and I should have maybe made a vertical run, but I'm gonna install my switch, let's say right here. We just remove a portion. Let's see here. Remove a portion of this. Doesn't have to be that big. All right, let's get this sucker to peel up. There we go. All right, so there you go. You've interrupted the circuit. Then we would put some glue on there and glue this bad boy down. Then we would just puncture the tape. I have a little thumbtack here. Just gonna give me a little starter hole. All right, let me line it up. Yeah, it looks fine. Okay, so now we have these two little starter holes. Now I would take my little drill and drill it. There we go. Drill this side. Okay, we got that. We got that. Just need some of those little eyelets. That's the new pack. Oh, I had some kind of left over somewhere. I probably do. Now that I open this, they're all gonna go missing. There we go. There's a few of those guys. So then I put a little glue on there. I had already, no, I would do this before wallpaper, excuse me, and then just cut around it. Place that guy there. We have our little tool. We set this guy right on here. And then, oh, this is fiddly. There we go. And then we just gotta push it in. That's one. Put this on here. Line this guy up. There we go. And that would be it. Right over here, I know this is, again, just an example, but the power would be coming this way. This would interrupt it. And then over here, we would actually hook our light fixture up. Let's see here. And then you could see how this little gauge here, if I'd use it to place it, but I would use this place on the ground, and then it lines up with this perfectly. And then we have all these little holes. Let's say if it was an outlet, I could, you know, pre-puncture in these little holes, line everything up. Anywho, this, or the LED strips, I use two different color LEDs. I had white, I put amber. This is really just a soft white. I use like a brighter white in the kitchen and the bathroom, and a softer one in the rooms. But open this guy up. Got 3 of them in here. You could cut it right at this this little junction here. It has an a self-adhesive on the back. You peel the back, and you could stick it over this wire, tape wire, and then I would puncture it right in these pads. You can see that. And then, just like you saw the other process, if I'm using large eyelets, I would drill it with this guy and then press it in with this. If I'm using small eyelets, which I don't have any left, unfortunately, and you can use the small ones for these, you can actually just puncture it with just this, no drilling, and put them in. This will press into the wood and make a hole just fine. All right, hope that helps.